everyone, welcome to Duodecimal Division. My name is Eric Larson and this is the 10th video in a series of videos that I've made called The Secrets of the Numerals, where I'm sharing with you how somebody in the past used this geometric pattern here as a template or as a source of inspiration to come up with the various symbols that we know as the numerals to represent the numbers, that inside each symbol, because of how they line up on this pattern, there's a lot of geometric information embedded within the symbol. The most obvious of which is the actual length or the value of the number that the numeral is representing is encoded within its design when you place it on the Cartesian plane. Obviously the Cartesian plane, lots of points in there, so there's always the opportunity for lines to have a specific length. And again, each numeral contains a line or a group of lines or some kind of demarcation of the value of the number that they're representing. So now we are at the 10th circle in this series. So this is the circle with the radius of the square root of 10. And I've drawn it here. I've made points where the lattice points define this particular circle. You know, we go over 1 and up 3. So 3 squared is 9 plus 1 is 10. But in duodecimal, it's not called 10. We have a different name for this symbol. It's called dec. D-E-C. And if you look at it, you can see the origins of that name from the words like decade or decagon or decimal. So all those words contain the value of 10, talking about 10 years or 10 sides to a polygon, that kind of thing. So that's the name of the symbol that I'm going to show you. And basically it looks like, I'll just write it up here, kind of like an X, but it's got these little kind of wings on one side, sort of a little wing going out that way and one going out the bottom, and the other side is just a straight line. So now I'm going to show you why it looks like that and how this symbol also has some geometric information encoded within its design. And so just to be clear, where I've got that information was from a number file video. It's the only place where I've actually seen that symbol used. Although since then I have found almost like a child's nursery rhyme called Little 12 Toes, which also refers to dec and L as specific symbols. So that's it. I haven't been able to find any more information about it, but I took that symbol, how it was written in the video, just on a piece of paper and kind of played around, first starting with these lattice points, but then changing it. And what I did was I ended up realizing that they used the dodecagon line again, the one that was more at, well, you already know what the dodecagon line is. That's the one that was used in the 3 and the 7. So I'm going to flip the board around so we can look at that one clearly, and I'll show you what I believe is the correct design for this particular numeral. Okay, so here we are on the other side where I've got the dodecagon lines lined up, and what I've done is actually drawn the whole symbol already because it's a little bit more complex than the others. I wanted to talk about it more than just drawing the lines and writing all the coordinate points. So I've written all the coordinate points, and what they've done, as you can see, is chosen this dodecagon line, and then they stopped at this point right here. So the distance from the x-axis, we're going up 1, 2.5 or 2.6 on the y. So 2.6 plus 2.6 is 5. So the distance between this point here and that point here is the length of 5. And then 5 plus 5 is 10, or dec. And so the reason for this little arrow or this little wing here coming out is we're going along this, remember this slope of this line is going up 1, then over 0.7, then up another one, over 0.7, then we're going to go up half. 1 plus 1 plus a half. So we go up half and then we go over 3.6. So we got 7 plus 7 is 1.2 in base 12, plus 3.5 is 1 minus 1.56. So that's the x coordinate of this point here. And then we're going to go that way 0.5. So then this point here is negative 1.A6, and actually I'm using A, but this is the same as this symbol is dec, so it's 1.A, and dec are the same thing. I just got in the habit of using A because that's what my calculator uses. So 0.5 for that line. Again, the decimal value, we got 0.5 here and 0.5 here. So of course 0.5 and 0.5 is point dec or A or 10. So the same on this side going down, but on down here, instead of having the wing and going on the other dodecagon line, they just went straight to this point. So these 2 points are exactly above one another. So the coordinate points of this one is negative 1.86 and negative 2.6. So again, so far on this, we've got the height of 5 on both sides, which adds up to dec, and we've got the decimal value on each side. So what we'll do is just see how close this point is actually to the square root of dec circle. So let's just do that calculation right up here. I guess it's going to be 1.A6 squared plus 2.6 squared. And you know, A squared plus B squared. So I've got that written down here. 1.A6 squared is 3.623. 3.623, and 2.6 squared is 6.3. So you got a total of 9.923. So this point here is the square root of 9.923 distance from the center. So that's basically, you know, 0.29 something square root of from square root of dec radius circle. So it's pretty close. So that's those are the 4 points on the edge. So you can see why they chose not to use the lattice points like they usually do, but chose those points instead. So far we've got the value of, you know, I'm going to write up here 2 times 5 equals, you know, I'll write the symbol like that, and we've got the decimal version. You know, I guess it's 2 times 0.5 equals point dec. Okay, that's that. So I'm going to put the whiteboard behind so you can see all that so far. Okay, so there you can see that a bit more clearly. So that's what that looks like, but there's more. As usual, what's happened is I just realized, or when I was making one of these videos earlier, I realized that there's even another geometric component to this symbol. So how we figure that out, what I'm going to do actually is draw this line in here, and that again has the length of 5. So if we want to find out, basically we know that 5 squared equals 21, so 5 equals the square root of 21. So what's this length down here? Well, we have these 2 coordinates, negative 1.A6 and 1.A6. So basically the length, if I was to draw a line along here to this point here, so that length line is going to have the length of 2 times 1.A6, and that is 3.9. 3.9. And so what we're going to do now is just figure out, okay, 3.9 squared is 12.09. Therefore, you can, I'll write it actually here, 3.9 is the square root of 12.09. So we got a right angle triangle here. A squared plus b squared. So that's square root of 21. I'll put that underneath here. Square root of 21 plus the square root of 12.09 is 33.09. So what's interesting about this is that 4 times 1.3 equals 5. Again, in base 12. So down here, it's really close to the bottom, but I think you can still see that 3 times 1.3 equals 3.9. So we have 3, a length of 3, and 4, 3 times 1.3, 4 times 1.3. What is 5 times 1.3? Well, that equals 6.3. So what is 6.3 squared? 6.3 squared equals 33.09. So here we are down here, 33.09. Can you see that there? Okay. What? Yes, you can see that already. All right. So there we go. So basically what I'm saying is this is a 3, 4, 5 triangle. Again, more geometric information encoded within that symbol. So that's why the numeral for dec looks the way that it does. The creators of the numeral managed to get a symbol that has the value of dec plus the decimal value of dec plus the 3, 4, 5 triangle in there. And I'm sort of guessing because I haven't really figured this out yet, but I'm wondering what the relationship is between the 3, 4, 5 triangle and the dodecagon, because they've got the dodecagon line in there also. So I'm having a lot of fun exploring all this and checking out the relationships between the symbol and the different geometry that they use to create the symbol. That's what I got so far on this one. There could be more in there. I'm still learning all this. So I hope you've enjoyed this presentation. Now you know why that symbol looks the way that it does. Now we're going to go to the last symbol in the series. It's a symbol called L, E-L. It's the 11th symbol in the series. So again, you can see the link in the words L and 11. And we're going to find out what it looks like. Again, I found out the symbol for that on Numberphile. That's in the next video. I hope you've enjoyed this one and that you join me for that one. Thanks for watching.